Welcome to tutorial 6 for Introduction to Chemical Engineering Design. So without further ado, let's move on to question 1. A mixture of propane and butane is burned with air. Partial analysis of the stacked gas produces the following dry basis volume percentages of, you have some amount of propane, butane coming out. You also produce carbon monoxide and CO2. The stacked gas is at an absolute pressure of 780 mm mercury, and the dew point of the gas, the stacked gas, is 46.5 degrees Celsius. Calculate the molar composition of the fuel. So what does that mean? And you are given the Antoine equation for calculating the vapor pressure is this, where T, the temperature here, is in degrees Celsius, and P, the vapor pressure here, is in mmHg. So we need to calculate the composition of the fuel. So let's draw it out first. Okay, you have your boiler here, or your combustion engine here. So you don't know the actual number of moles of propane and butane that goes in. Neither do you know their composition. Now, you have to burn your fuel with air, right? So you have air coming in, which of course the composition is fixed, which is 0.21 of oxygen and 0.79 of nitrogen. And then you have your stacked gas, which composes of the following components as given in the question here. Okay, these 4 components over here. Well, of course, you may have oxygen and nitrogen in your stacked gas also. In this case, we are taking 100 mole of dry stacked gas. Okay, more properly, it's dry stacked gas. Okay, because it says here dry basis volume. Okay, that's why we take it as dry stacked gas. And of course, you have H2O, water vapor coming out in your stacked gas. But if we include the number of moles of H2O or the water vapor, then it will be in wet basis form. That is why we take our basis as 100 mole dry stacked gas. So first off, using our Antoine equation, we calculate for our vapor pressure of the water, where temperature is the dew point of the gas of 46.5 degrees Celsius. Right? So you get your your vapor pressure of your water of 77.6 mm mercury. Now, if you may ask, do I have to remember this equation here, or will this equation always be given? Now, don't worry, because you will most likely be given, mostly actually, you should be given the supporting documents, or your supplementary material, here, and you should get the Antoine equation along with their parameters A, B, C. So just substitute them in and you can calculate for your vapor pressure. Now you must remember to take note of the units for the pressure and the temperature here. Make sure you convert them to the correct units first before performing the calculation. So there's an updated table in Canvas, so please download that one. This one is not the updated form. So moving on, you have found your vapor pressure of your water. Now you are given that your dew point is 46.5. Yes, we know because we have calculated for this. So we can calculate the mole fraction of H2O. Okay, mole fraction of H2O using this equation, which is YW is the mole fraction of water in vapor phase. P is the total pressure of the stick gas, which is 780, and this P star W here is your vapor pressure of your water at 46.5 degrees Celsius. So we have already found this, so this value is 77.6. P here is 780. So we get the mole fraction of water to be 0.0995 mole. Okay, but over here, this one is in the mole fraction over here, or the composition of the gas over here is in dry basis. Therefore, when we want to look for the number of moles of water, you have to take consideration that it is in wet basis. The mole fraction of water is in wet basis. So the mole fraction of water, YW, which we have found here, is equal to the number of mole of water divided by the total number of mole coming out at the outlet stream, which is the number of mole of the dry gas plus the number of mole of water vapor. Okay. Then we can solve for the number of mole of water vapor to be 11.05 mole. Now we want to look for NP and NB over here, right? So I hope you remember your elemental balance. If not, please refresh. So we will do elemental balance for the element C and H. Same thing, whatever number of moles of C that goes in equals to the number of moles of C that goes out. So the component that contains C is propane and butane. You have 3 moles of carbon per mole of propane and 4 moles of carbon per mole of butane. Okay, so since this one is in mole fraction, we will have to multiply by their number of moles of the stick gas. So this one, you have your propane coming out, your butane coming out, and you have your carbon monoxide CO coming out, but because you only have 1 mole of carbon per mole of CO, so it's multiplied by 1. We're not going to write that in. Same goes to CO2. Okay, and you will get this equation. Do the same for H, but don't forget that for H here, we also have H2. So remember to include your H2O, your H balance, your H2O in your H balance, and you will get equation 2. Solve equation 1 and equation 2 simultaneously to get this. So how do you get the composition? Simple. Take the number of moles of propane, for example, and divide it by their total number of moles, which is 1.25 plus 1.3. Okay, this one is very simple and very direct mathematics.